there, welcome back to this video of Rust. Today we're going to explore one of the most important parts of writing Rust, which is error handling. Well, it's mostly when there's something going wrong with the code. Maybe a file missing, maybe some input makes no sense. That's why we're gonna look at three things: the panic, result, and the question mark operator. Well, without further ado, let's jump into it. Rust has a way of splitting the failures into two kinds. On the left, we're seeing a panic, which means the code itself is wrong, and you might have indexed past to an array or unwrapped something that wasn't there. The thread unwinds and the program just stops. There's nothing to recover because the bug is kinda yours to fix. And on the right, a result. This means something might fail for a reason that you have already expected. A file might not open, a text might not parse. This isn't a bug. This is a way of Rust handles failure as a value, which also lets you decide what you can do. It's more like a rule that if a user hit with this, return a result. It means your code is broken, then you can just put panic. Let's try to understand what actually happens for the code to fire a panic. Well, it turns out a bunch of things, and they're kind of worth understanding. So, it could be indexing past the end of a vector. It could be calling unwrap on a none, integer overflow, or like in a debug build or something, a failed assert, or the macros that you can fire on purpose, like the panic itself plus some to do that is like unimplemented and also unreachable. Every one of these means the code is wrong. There's nothing to catch, but there's something to fix with your code. When a panic fires, you can have two ways the program can wind it down. Well, by default, Rust unwinds, like it walks back up to the stack and runs every destructor, then exits cleanly. But you can switch that to abort, which stops immediately and hands cleanup to the operating system. That's a build setting covered properly, probably in one of the next episodes. Now, when a panic prints, it tells you to run with the Rust BACKTRACE set to 1. Do that and you'll get a full chain of calls that lead to crash. Usually, how you can find the line that's actually wrong. And that's the work. So, when do you think panic is the right call? Well, it might be surprising, but it's more often than you think. It's like a quick prototype where you want to move fast, and a crash is just fine. In test, where a panic is how your failure kinda gets reported to you. In examples where handling every error would bury the point. Now, anywhere the world, there can be break of the contract, a user, a file, a network, a piece of input that you didn't write, and it returns a result, but given the caller a chance to handle it. Panic on bugs and results on mostly expected failure. That's the whole rule. Here, it's a different place where panic belongs. It's more like you're enforcing your own rules. You can start with a tiny wrapper around an integer, maybe a guess that holds an i32 or integer 32, nothing else. Then give it a constructor. The only way to make a guess is through this new. The function returns a result, so a bad value can refuse to construct 1. Now, inside, you can check the rule once. The value has to be between 1 and 100. Anything else returns an error. Right there. The check lives in exactly one place. Now, every function downstream that takes a guess can trust it. No more range checks scattered through your code. The type itself carries the invariant. Now, here's the whole thing. Result is an enum with two variant. Okay, holding the value you wanted an error, holding the errors. Two types parameter, and T is for success and E is for failure. So to read it, you have to match. You can put one arm for OK and one arm for error. The compiler will not let you forget either one. If you only handle the happy path, the code does not compile at all. That's not the whole part of the result. Well, the failure is right there in type, impossible to ignore. OK holds maybe this cat and error holds the load error, and you decide what to do with each. You can also take a look closer at that error, like an IO error has a kind. You can match on that kind and react to not found differently from permission denied. It's like same value, but you can add more details when you want to add it. If you try to match every time, it could get quite noisy, and that's when result comes with a shortcut for the common moves. Over here, map transforms the OK value and leaves the error alone. Map error does the opposite. It rewrites the error and leaves OK alone. And then the change together, another operation that itself can fail. Then there's the family that gives you a value no matter what. Unwrap or handles back a default, and if it's an error, unwrap or else. Compute that defaults with a closure. Unwrap or default uses the type's natural default. And OK or turns a mission like option into a real error. Reach for this when logic is a clear liner mostly, and reach for match when it's not. And results are kind of related. The both of them might not be like a plain value. It's more like the difference why you use them. So option is either some or none. It kind of tells something that might be missing with no explanation attached. And none is just tells you that it's none or nothing value. And for result, it's OK or error. The error carries a reason. It tells you what went wrong. You can move between them. You can call OK or on a result to drop the error or get an option, or you can call OK or an option to supply an error to get a result. Now, the question mark operator actually works on both, and that's what we're going to explore now. Carrying out all these errors by hand is quite exhausting. It's like match or return early. You open the file, you match them, or you return, or you read the file, then you match or return. Every call doubles the size of code, and that kind of becomes unreadable. But the question mark operator solves all of this. If you put a question mark after a call that returns a result, if it's okay, and you get a value and it keeps going. Or if it's an error, the function returns the error right there. It's same behavior and way fewer options or keystroke. So the question mark in a way is like, if error, you just return it. If okay, you just unwrap that. The question mark kind of looks like magic, but Well, let's see why it does when it expands to the same match. On OK, pull the value out. On error, it just returns early. But it does one more thing. On the way out, it converts the error. So if you open return to IO like error, the question mark calls from, and your load error is what comes out. Parse return, parse int error. So it's like a same trick. One return type unifies many error sources. The question mark works on option 2, like non-short circuit. It's like same way error does. You can use it in main too. If main returns a result, there's the one place at the very top where it just works. Now you load cat call and can return its error, and main hands it back to the OS or operating system. It's like this one single character did all of that. There are two shortcuts that you'll notice everywhere, which is unwrap and expect. Unwrap kinda says that you give me the value, and if it's an error, I'm just gonna panic. No message and no context whatsoever. Now for the expect, does kinda similar thing, but you kinda give it the message that it prints out when something goes wrong. Always kinda prefer to use expect because if you wrote it down like that, it kind of saves you or tells you later what actually went wrong. Here's when they're both honest. During prototypes, where you want to move fast, test, where a panic is how you just fail, and cases where error truly cannot happen. Now, here's when they lie, like reading a file when user choose a network call or a parsing input, or unwrap there is not a shortcut. It's a crash that's probably just gonna wait for a bad day and happens when it just returns a result. So yeah. A function call can fail in more than one way. You want one error type that covers all of them, of course. So you can make an enum, one variant for each failure type. For the cat loader, one for file IO and one for the parse. To make it a real error, you implement two things. First, display. That's the human readable message your callers see when they print or log this error. And second, the error trait. That's what lets your type slot into the rest of the error ecosystem, like source chain, downcast, all of it. Then the piece that ties it all together from implement from for each underlying errors. Now when you write a question mark, it knows how to convert an IO error or a parse error into your type automatically. Writing display and from by hand gets quite repetitive, so most people reach for a crate, and which is like this error generates all of that from one derive on enum. Then on each variant, a couple of annotation, an error message string, and this from to mark which source error it covers from. The macro writes the rest. If you don't even need named variant, there's a shorter path. Return a boxed error, and any error type flows up. It's really quick to write, but callers lose the ability to match the specifics. The rule most people settle on this error is when you're writing a library because your callers want to match on your variant. Anyhow, when you're writing an application because you're mostly just want an error to bubble up the context. Thing to keep in mind, errors are values, not exception throws in the dark or not crashes and you kinda never expect it to happen. data the type system carries with you until you decide what to do with them. And that's all there is for error handling. You can fail loudly when it's a bug, and you can recover magically when it's not. Well, on the next video, we're gonna explore generic traits and write something fun. So, thank you so much for watching. See you on the next one.